Have you ever stopped to watch a soap bubble floating through the air and wondered why it's always round? Whether it's bubbles in your drink foam in the ocean or soap bubbles drifting in sunlight, they all share the same near-perfect spherical shape. This isn't a coincidence or just a visual trick, it's a beautiful result of physics, chemistry, and nature's constant drive toward efficiency. Understanding why bubbles are round opens a window into how invisible forces shape the world around us, from tiny droplets to entire planets. At the heart of a bubble's shape is a powerful concept called surface tension. Liquids are made of molecules that attract each other. Inside the liquid, these attractions cancel out because each molecule is pulled equally in all directions. But at the surface, molecules don't have neighbors on all sides, so they are pulled inward. This creates a kind of skin on the liquid's surface that tries to shrink as much as possible. Surface tension always works to reduce the surface area of a liquid because a smaller surface area requires less energy to maintain. Now here's the key idea: a sphere has the smallest surface area for a given volume. Among all possible shapes that can hold the same amount of air, the sphere wins the energy efficiency contest. Nature loves efficiency. When a bubble forms, surface tension pulls the liquid film evenly from all directions, naturally shaping the trapped air into a sphere. The bubble becomes round, not because it wants to be beautiful, but because it wants to be stable and energy efficient. Soap bubbles add another layer of science to the story. Pure water bubbles don't last long because water's surface tension is so strong that the film collapses almost immediately. Soap molecules change everything. They have two ends, one that loves water, hydrophilic, and one that avoids it, hydrophobic. When soap is mixed with water, these molecules arrange themselves along the bubble's surface, reducing surface tension and stabilizing the thin film. This allows bubbles to stretch, float, shimmer with colors, and survive long enough for us to admire them, while still staying round due to the same surface area rule. You might wonder why bubbles sometimes look squished or flat instead of perfectly round. The answer lies in external forces. Gravity can pull liquid downward, air currents can distort the surface, and contact with other bubbles or surfaces can alter the shape. But when a bubble is freely floating in the air with minimal interference, it quickly returns to a spherical form. This self-correcting behavior shows just how strongly surface tension dominates bubble geometry. Interestingly, bubbles also help scientists understand much bigger things. The same principles that shape bubbles apply to raindrops, planets, and stars. Small raindrops are round for the same reason. Surface tension dominates over gravity. Even planets become spherical because gravity pulls matter evenly toward the center, minimizing energy in a similar way. In a sense, every bubble is a tiny model of how the universe organizes itself. Bubbles also reveal complex behavior when they come together. When multiple bubbles touch, they don't stay perfectly round. They rearrange themselves into shapes that still minimize total surface area across the group. This leads to beautiful geometric patterns seen in foam honeycomb-like structures and even in biological systems such as cells. What looks playful and simple is actually governed by deep mathematical rules. So the next time you see a bubble floating by, remember that you're watching physics in action. That perfect round shape is the result of molecular forces, energy minimization, and nature's preference for balance and efficiency. Bubbles may seem light and temporary, but they carry powerful lessons about how the natural world works, quietly, elegantly, and always following the same fundamental rules. If you enjoyed this deep dive into everyday science and want more fascinating explanations like this, like the video, share it with curious minds and subscribe to the channel. There's a whole universe of simple wonders waiting to be explored, one bubble at a time.